All right, this is grade 6, unit 2, lesson 11. And in this lesson, students are going to be moving from that double number line, which is nice and it's great and it's this visual representation. But now we're going to move from those double number lines towards using a ratio table. And that ratio table is not quite as visual, but in a lot of ways it's easier to kind of manipulate. And so we're going to start introducing the ratio tables in this lesson. In this lesson. So let's get started. So we're going to start with a number talk. And it says, look for patterns in these figures. How many total tiles will be in the fourth figure, which would be right here, then the fifth figure, the 10th figure, how do you see it growing? So the idea is, parents and teachers, what we need to do is allow our students the opportunity to look for patterns. What are they noticing going on here? And we can see in this first figure, it's got a 3 and then a 4. And then the second figure, it's got 2 3s and 2 4s. And then in our third figure, it's got 3 3s and 3 4s. So basically, if we wanted to kind of write that out as an expression, we have one, whoa, I don't want to do, that's big old, way too fat. So let's do, all right, so let's get smaller, thinner pen. Here we go, right here, good. All right, so we've got one copy of 3 plus 1 copy of 4, all right? And then right here, so let's move that out of the way. Let's get that, let's just leave it there, apparently. And then on this one, what do we have? We have 2 copies of 3 plus 2 copies of 4. So I'm going to write that as 2 copies of 3 plus 2 copies of 4. And then in the same way, what do we have in this third figure? We have 3 copies of 3 plus 3 copies of 4. So the idea would be, so what is that fourth figure even going to look like? So it says how many total tiles will be in that fourth figure. Well, we can sort of predict. We had 1 copy of 3 plus 1 copy of 4. We had 2 copies of 3 plus 2 copies of 4. We had 3 copies of 3 plus 3 copies of 4. So we see that 1, 2, 3 copies. So we can predict this next one is going to be 4 copies of 3 plus 4 copies of 4. Now, if we wanted to test that out, all we have to do is reveal, wabam, and there is my kind of a lame drawing, but it's showing, here's your 4 copies of 4. Here's your 4 copies of 3. So there's your 4 copies of 3 plus your 4 copies of 4. And so there's our first figure, our second figure, our third figure, and we have officially found our pattern for our fourth figure. So what's that fifth figure going to be? It's going to be 5 copies of 3 plus 5 copies of 4, right there. And what is the 10th figure going to be? It's going to be 10 copies of 3 plus 10 copies of 4. Now, folks, there are other ways that a student might have looked for patterns. In fact, we can sort of, let's see, how might I do this? Let's see, I'm going to zoom. No, that's not what I want to do. I don't know. I can say, like, we could say, well, here's 6 plus 1, and then here is 12 plus 2, and then here is 18 plus 3. So we might see a different pattern based on seeing the shape in a different way. That is a very rich number talk. So we're gonna work on this. This one, it's called a huge amount of sparkling orange juice. Now, the idea is, at parents and teachers, is we're going to help students start to see that this double number line is really awesome, and it's a very wonderful visual representation. But sometimes it gets a little bulky when you start to deal with large numbers. So let's move this up and says, all right, Noah's recipe for 1 batch of sparkling orange juice uses 4 liters of orange and 5 liters of soda. Use the double number line to show how many liters of each ingredient to use. And of course, we're going to start with the idea of zeros, because whenever you have 0 water, then you have 0 juice right there. All right. And so if we want to do 4 liters of orange juice and 5 liters of water, we can record that right here, 4 and 5. And there it is. Now it says use the double number line to show how many of each ingredient to use. All right. So we could do then like 8 and 10, and then 12 and 15, and then we could do 16 and 20, and we could just keep going and going and going and going and going. So it says if someone mixes 36 liters of orange juice and 45 liters of soda water, how many batches would they make? So we're going to just keep going, aren't we? So we've got 16. Oh, add 4, add another 4 is 20, add another 4 is 24, add another 4 is 28, add another 4 is 32, add another 4 is 36, add another 4 gives us 40. And then down here, as a consequence, we also have to be going up by 5 because the ratio is 4 to 5, right? So then we're just going to keep going. We got 25, 30, 35, 40, 45, and 50. So the question is, if somebody made 36 liters, mixes 36 liters of orange and 45 liters of soda, that's right here. So how many batches did they make? Well, that's 1 batch, 2, 3, 4, 5, 6, 7, 8, 9 batches. So they did 9 batches. Whoa. 9 batches. So now, continuing on, if somebody uses, oh my goodness, 400 liters of orange juice, how much soda water would they need? Well, we have this ratio right here, right? It's 40 to 50. So if they use 400 liters of orange juice, basically what we're doing is we're going from here timesing by 100 to give us 400 liters of orange juice. So what are we going to do down here? We're going to times by 100, and that gives us 500 liters of soda water. 500. And then it says if somebody uses 455 liters of soda, how much orange juice would they need? 455. Oh my gosh. So now it's getting a mess, aren't we? Because now we have to figure out 455 liters of soda water. So, well, 455 liters of soda water. Well, 450 would be multiplying this. So that would be by 10. So that would give us 450 liters of soda, would give us 360 liters of orange juice, right? Right there. But then we need 5 more liters, because it says right here we need 5 more liters. So we can use this ratio right here. 5 more liters of soda gives us 4 more liters of OJ. So that gives us 455 to 365. Whoa, 365. Now we're starting to see, explain the trouble with using double number line. Well, it starts to get bulky. The numbers start to get large, and it's hard to fit everything in. So the idea is, how do we connect this to a table? And so our idea would be, so we've got, let's see, orange juice and soda water. And we were given that initial ratio, and I don't remember what that initial ratio was. What was that initial ratio? The initial ratio was 4 liters of orange juice to 5 liters of soda water. So our initial ratio is this 4 to 5 right here. And the idea is we can multiply by anything we want as long as we do it to both ingredients. For example, if I take this and I multiply by 10, that gives me 40 liters of orange juice. Well, then we have to do the same thing over here. Multiply by 10, and that gives us 50 liters of soda water. And now all of a sudden it becomes super, super easy. I mean, I could take that 4 and I can multiply by a half. That's the same thing as dividing by 2. And that would give me 2 liters of orange juice, in which case I would have to do the same thing with the soda water, multiply by a half, which is the same thing as dividing by 2. And that gives me, in this case, 2.5 liters of soda water. And anything we do to one ingredient, we would need to do to the other. For example, so if we take, in terms of multiplying and dividing, right? So if I take that 4, and if I wanted to multiply by, I don't know, take that 4, I can multiply by 110. I don't know, I'm just saying, 110. So that's going to give me 440 liters of orange juice. So what am I going to do with this 5? I'm going to multiply it also by 110. That gives me 550 liters of soda water. So yeah, the idea is these tables are supposed to be easier for us to use than that double number line. The double number line is nice, but when the numbers start to get big, the number line starts to lose its value, in which case we're going to want to move to a ratio table. So let's put that into practice. So it says a recipe for trail mix mixes 7 ounces of almonds with 5 ounces of raisins. So there's our ratio right there. Here's a table that's been started. And then our job is to fill in the rest of these values. And we can see that, well, moving from 7 to 28 was a times by 4. That means we're going to times by 4. And we're going to get 20 ounces of raisins. And then what are we going to do to get this 3.5? Well, you could go, over here, we have a missing number here. So how do we go from the 5 to the 10? Well, we doubled it, didn't we? So we doubled it here. So we can do the same thing. We're going to double it here, and that gives us 14. And then the idea is, well, how do we get 3.5? Well, that's half of 7. So 7 times a half gives us 3.5. And so 7 times a half gives us 3.5. So we're going to take that 5 times by a half, and that's going to give us 2.5. Continuing on, well, we have a blank right here. So how do you go from 5 to 250? Well, you multiply by 50. So that 5 times by 50 gives you 250. So we're going to do the same thing. We're going to take the 7 times by 50, and that gives us 350. And then the last one, 7 times 8 is 56, right here. 7 times 8 is 56, so we're going to do 5 times 8, and that gives us 40. So we've filled in the table. So what methods did you use to fill in the tables? We're looking for multiplication. What did we multiply for one ingredient? And then we're going to multiply the other ingredient by the same amount. So how do you know what that each row shows a ratio that's equal to 5 to 7? Well, we know that every single one of these ratios is equal to 5 to 7 because we took that original ratio and multiplied both ingredients by the same value each time. So that tells us all of these ratios are equal to the original ratio of 7 to 5. That brings us to the summary, which is really that double number line has its place. We like the double number line. It's very visual. It's easy to use. But then eventually, sometimes those numbers get bulky. And instead of using that double number line, we're going to think of the table. And that table just allows us to deal with a more a wider range of numbers, I guess, maybe. It's going to keep all of these ratios are equal or equivalent if every time you multiply one number by something, you multiply the other number by the same thing. And so these are all equivalent ratios, and the big word today is table. I call it a ratio table. So now it's time for us to just kind of do some practice, right? So it says complete the table to show the amounts of yellow and red paint needed for different size batches. Explain. So here it goes. It's totally up to us. We get to choose. We just have other rows to fill in. We need to remember whatever we multiply the 5 by in this case, we have to multiply the 6 by the same thing. So let's say we multiply by 3. So that gives us 15. So multiplying by 3 gives us 18. We could do multiply by, 12. So that gives us 60. So 6 times 12 gives us 72. And then we can get crazy. We can say, well, let's multiply by 100. So that gives us 500 quarts of yellow paint and 600 quarts of red paint. So here we've got a car that's traveling at a constant speed as shown on the double number line. And then it asks us, the key question right here is, how far is that car going to travel in 14 hours? So quite honestly, here's what I'm going to do. I'm going to switch this over. I'm going to make it a table. We've got hours and we've got kilometers. And we could put any of these ratios, because except for the zeros, but I could take any of these ratios and put it into the table. Let's put 1 and 70. Heck, we could put them all. 2 and 140. And we could put 3, 210. All right. So there's our 3 ratios. Now, keeping in mind, we need to figure out how far does the car travel in 14 hours. So really, we want to know 14 hours right there. How far will it travel? Right here is our question. So which numbers multiplies nicely to give us 14? Well, I could either do 1 times 14 to give us 14, or we could do 2, and I want to do it in a different color. Let's do it blue. 2 times 7 to get us 14. So let's do that. Let's do that one. 2 times 7 is 14. So we're going to multiply 140 by 7, and that's going to give us 980 kilometers, because 140 times 7 is 980. So now we know that car will travel 980 kilometers in those 14 hours. More of the same, the olive tree in an orchard produces 3,000, 3,000 pounds of olives a year. It takes 20 pounds of olives to make 3 liters of olive oil. How many liters of olive oil can this orchard produce in a year? So the idea is, here's our table. They've given us this ratio that for 20 pounds, it creates 3 liters of olive oil. And our job is to scale up to figure out how many liters would 3,000 pounds equal. So they gave us this intermediary number here, 100. So let's take advantage of it. So 20 times 5 gives us 100. So 3 times 5 gives us 15. So 100 pounds of olives gives us 15 liters of olive oil. And now we can go from 100 to 3,000 pretty easily. We know that 100 times 30 there gives us 3,000. So that means we need to take that 15 times by 30. And what is that? That's going to be, let's see, 3 times 15 is 45 plus the 0. 450 liters of olive oil. My goodness, that's a lot. 450 liters of olive oil. All right, so they're giving us more of the same, only this time they're asking us to specifically to use a double number line. So it says a school recess needs a ratio of 2 adults to every 24 children. So there's our ratio right there. The double number line represents the adults and the children. Label each of the remaining tick marks. So we can see that our adults are 2, 4, 6, and 8. That means the the number of children. For every 2 adults, you have 24 children. So our children, we need to just keep adding by 24 every single time. So that's going to be 48. Another 24 is going to be 72. And then the remaining 24 is going to give us up to 96. So there's our equivalent ratios. It says how many adults are needed if you have 72 children. Well, we can see it. It's right here. 72 children gives us right there 6 adults. Now it doesn't ask us to, but we could put this into a table, couldn't we? So we could say adults and children. And we see that our given ratio is 2 adults equals 24 children. And if we wanted to know how many adults are needed for 72 children, we can see that, well, 24 times 3 gives us 72. So 2 times 3 gives us 6. So this is how we show it in a table, and up here is how we show it with that double number line. While playing basketball, Jada's heart rate goes up to 160 beats per minute. Dang. While jogging, her heart beats 25 times in 10 seconds, assuming her heart beats at a constant rate while jogging. Which of these activities resulted in a higher heart rate? Explain your reasoning. So really what we need to do is we need to think about how do we connect this ratio of 25 times in 10 seconds, how do we relate that to 160 beats in 1 minute? Well, the idea is we know that there's 60 seconds in a minute. So if we take, and we could do it in a double number line, it doesn't really matter. We can do a double number line. And there's our zeros right here. And let's call this seconds. And let's call this heartbeats. And so we got 0 heartbeats, 0 seconds. So we do have, if we have 10 seconds, that gives us 25 heartbeats. So we need to work our way 20, 30, 40, 50, 60. 20, 30, 40, 50, 60. And so every 10 seconds, it gives us a heartbeat, 25 heartbeats right here. So if you have another 10 seconds pass by, that means our heartbeats are going to be 50, then 75, then 100, then 125, then 150. So there's our 150 heartbeats in one minute. Oopsies. And there we go. In 1 minute right there. And so jogging or basketball, well, we could see that basketball was 60 beats, 160 beats in a minute, whereas jogging was only, so to speak, only 150 beats in that minute. Doing a little bit more review, we've got a shopper bought the following items at the farmer's market: 6 ears of corn for $1.80. What's the cost per ear? So the idea is we need to figure out if you only bought 1 ear of corn, how much would that have cost? And so we can make a double number line, and that double number line would start with this 6 ears of corn costing us $1.80, and then we have to cut it in half, and then we need to somehow get down to just 1 ear of corn, And how much would that 1 ear of corn cost? And I'm going to let you grapple with your double number line because this is a really good review, so I'm not going to mess with that. Same story here. Create a double number line for your apples and the cost, and work your way down using a double number line to figuring out what is the cost of a single apple. Same story here to find the cost for a single tomato. The idea is we don't want to forget that the beauty of those double number lines. The idea being, here's our tomatoes and here's our cost. 0 tomatoes costs $0. But if we have 5 tomatoes that cost $3.10, how do we figure out the cost of a single tomato? Well, 1, 2, 3, 4, 5. We need to take those tomatoes and cut them up into 5 equal pieces, right? 1 tomato, 2, 3, 4, 5 tomatoes, which means we're going to do the same thing with our cost. We have to cut our cost into fifths. 310 divided by 5, and that's going to give us that cost of that single tomato. What beautiful visual representation. Double number lines are just really kind of cool. And that wraps up grade 6, unit 2, lesson 11. Students were taking their understanding of the double number line and connecting it to this new thing called ratio tables.